Welcome to the video for Chapter 10, Lesson 4, Area of Triangles and Trapezoids. The lesson essential question is, how do we find the area of a triangle or a trapezoid? We've been dealing with triangles for a while, and the formula for area of a parallelogram and a triangle are distinctly related because every triangle is simply half of a parallelogram. So parallelograms technically have a base and a height, and so the formula for area for a parallelogram is just base times height, and that height can be shown inside the parallelogram or also outside of the parallelogram. Either one would be fine, but it is the actual height. It is not this slanted length here, so just keep that in mind with the parallelograms. Now this is a parallelogram, and as you can see in this diagram, there are two triangles. We split the parallelogram in half, and that would be the area of one of the triangles. So there are two ways to show this. We can take that base times height, get that answer, and then divide that by 2, or what we are most commonly used to seeing it is 1/2 base times height. So that's the formula for area of a triangle. Let's dive right in with some area problems. I'm going to move quickly through this because we are so used to finding area of triangles. This is not new material. So in this particular example, the 38 is going to be considered the base simply because that's the side that the triangle is laying on. The 21 would be the height. So we're just going to use 1/2 base times height to get our answer of 399 meters squared. Please make sure you do pay attention to the units when necessary. When we are dealing with area, the units become squared. With this example, we just want to remember that the altitude or height of a triangle, especially an obtuse triangle, needs to be identified on the outside of the triangle. So in this case, this is still the height, the 20 is still the base. This distance here does not matter when we are running our calculations, because if you included that, then we would be finding the area of a right triangle, and we don't have that. So we are just going to do 20 as the base and 17 as the height. And using the formula 1/2 times base times height, it's going to give us an area of 170 inches squared. This one is pretty cut and dry, so go ahead and take a minute, pause the video, and try this one on your own. Using the 9 as the base and the 6 as the height, you should find this area to be 27 square inches. Okay, moving on to the area of a trapezoid. Please remember that a trapezoid is not a parallelogram because the trapezoid only has one set of parallel sides, and then the other set, normally the left and right side, whenever we look at a trapezoid, normally the left and right side are not parallel. The top and bottom pieces that are parallel, we call those bases, and it doesn't really matter which one you put with a little 1 or a little 2, remembering that these little numbers are numbering, simply just numbering the sides or numbering the items. So in this case, we're numbering the bases. This is the first base, this is the second base. In the second trapezoid here, it'd be the same thing. That's the top base. So it's the first one. I'll just call this one the second one. These are just two different examples of the most common looking trapezoids because the left and right, again, are not parallel, but the top and bottom are. We could turn either of these shapes, especially the one on the right there, we could turn it so that it's actually laying on this side part over here, one of the non-parallel sides. Even if it looked like that, please understand that this would still be B1 and that would still be B2 because the B's are coming from the parallel sides. So that's the important part. They don't actually have to be bases on the top and the bottom. They have to be coming from the parallel sides. And what we're ultimately trying to get at here is this formula where it's 1/2 the height multiplied by the sum of the two bases together. So it is important that you know the lengths of the bases and which sides of the trapezoid are the bases, and then the height also. So in these three examples, this measurement in here would be the height, so it's already a dashed line over there, that's the height. Then the side of this would be the height, and then so it's sitting on it, that would be the height there. And so then we're just using that formula, plugging in as necessary, again, just paying attention to where those base numbers are coming from. All right, so taking a look at this trapezoid, understanding that I'm going to be using the formula 1/2 times the height times the sum of the two bases. So my bases are going to be my top and my bottom of my, in this diagram at least, but they are the length of my parallel sides. And in this case, with the way this trapezoid is set up, the height, or if 10, is labeled inside of the trapezoid, and so we're just going to plug those numbers, 1/2 of 10 times the 9 plus 25. So that's going to give us 170 centimeters squared, still area. So the units are still going to be squared. The other thing I'm going to point out to you at this time is that some formulas will have the H on the end, but since it is just multiplication, it would still be 1/2 times 9 plus 25 times 10, still doing that same multiplication, so it doesn't really matter. As long as you're entering it into your calculator correctly, you should get 170 square centimeters. Next problem, we have that the 4.5 centimeters is the height, the 6 and the 10 are the lengths of my two parallel sides, so that's going to be my base 1 and my base 2. So using the formula, 1/2 times the height times the sum of the two bases, just plugging all that into my calculator gives me 36 centimeters squared. I do not have to show that this is 16. I do not have to show a breakdown of all the multiplications. Like, you can just plug this whole expression in your calculator to get the final answer, but that's why it's important that I do see some sort of expression. Whatever you are plugging into your calculator, please make sure you are showing that work. This final example for the trapezoid finally has the height on the outside of around the perimeter of the trapezoid. It doesn't change anything. The top and bottom in this case are the parallel sides, so they're going to be my B1 and my B2, and I'm plugging in 14 for the height. So 1/2 of 14 times the sum of the 30 and the 40 together is going to give us 490 feet squared for the area of that trapezoid. So that completes the fourth lesson for chapter 10 on area of triangles and trapezoids. So we find the area of a triangle by using the formula 1/2 base times height. Find the area of the trapezoid by 1/2. You can put the base and height, the bases together and then the height. Again, I said the order of that multiplication doesn't really matter as long as the bases, the parallel sides, are the two that are being added together. Neither of these formulas are brand new to you this year. We have seen these in several previous math classes. So hopefully this is an easy lesson for you. Thanks for watching.